Welcome back to my tutorial series on how to make a game using Flutter and Flame. In this episode, we're finally adding in our scrolling background. We're also being able to spawn fruit and for our player to collect them. We have a lot to do, so let's get started. To get started, we first need to go into tiled and make sure that we're on our level because we need to add a custom property to our level that we can use to dictate what the color of our background is. To do this, we can go to our background layer, and then over here where it says custom properties, we can scroll down to the bottom and hit add property. The property we're going to add is going to be a string, and then we're going to call it background color, and we can hit OK. We now have the ability to give it a value. We can make this whatever color we have. To start off, we'll just do gray, and we can hit enter to make sure that that's saved in there. And then we can hit Control S to save our level, and now we can go back to our code. Once we're in our code, we want to make sure that we don't forget to import our assets. I always do, so we're going to do that first. We can go to our pubspec YAML, scroll down until we have assets, images, and then terrain, and then we can just hit Alt-Shift down to duplicate that, and then change the terrain to a background. Essentially what we're doing is grabbing our assets, images, and grabbing this folder right here, which has all of the colors of the backgrounds that we could use. The backgrounds are tiles, as you can see, in case you haven't opened this up yet, and this is what we're going to be using to make our backgrounds. So now that we've added that in and saved it, we can close out of that, and we need to go into our components folder under our lib folder and open up our level.dart. Now our level.dart file is getting a little cluttered, so what I want to do is clean this up before we can continue, and we can do that by just adding in some more methods just to kind of separate our code. So we can make a method. The first method is going to be underscore scrolling background. This is what we'll be working on in our video today. We can hit Control period and create a method. Perfect. We can also make another one for our spawning objects. So we can do underscore spawning objects. We'll be using this as well, and then Control period, create a method. And then the last one is we can do underscore add collisions. We don't really need to add these collisions in this video, but we did in the past, so we can create those methods. Then we just want to grab the final spawn points later, the whole way down to our if, Control X to cut that out, and then paste that into our spawning objects. And then we can do the same for our collision layer and all the code needed. Make sure you also grab the player.collision blocks. We can hit Control X and paste that into our add collisions and then save that. And now you can see our code is much cleaner. We can actually minimize these just to clean up the code even better. That's one good thing about methods, putting everything together, and then when you're not using it, you can just hide it. We should be able to still have our game work as normal, which is perfect. So what we want to do now is we want to work on our scrolling background. So first what we need to do is we need to get access to our layer that we just used and put the custom property on, which was our background layer. So we can do final background layer, and you probably already know how to do this because we've done it many times. We did it with our spawning objects and also our collision, and essentially we're grabbing our layer. This one's a little bit different though, so we'll do level.tilemap.getLayer, and this one we don't actually have to pass in object group because this layer is not an object group, so we can just give it the name, and the name is background. If you're not sure what the name is, again, it's the layer name on our tiled project, which we called background. Perfect. So now we have access to our background layer. What we want to do is we want to do like what we did before and make sure that it's not equal to null so that we don't get any errors in case you don't have this background layer, you forgot to add it, or you spelled it wrong or anything like that. It doesn't crash the game. There might be a layer that might not have it. I'm not sure, so it's good to check if it has it to begin with. So we'll do if background layer is not equal to null, then we'll actually do stuff with it. So the first thing we need to do is we need to get access to that background color, get the value that we passed in our custom property. And we can do this by doing final background color, and then we need to grab that actual property. And the way to do that is very simple. We can do final background color. We can do background layer dot properties. And then we can actually just call get value. There's a get property and a get value. We already know what property we want, so we can just pass in that property and then get the value of it. And that's what we're doing here. So we'll do background color. Perfect. And then semicolon, right? Perfect. So now we have access to our background color that we can then pass in to our background. So what we need to do now is we just need to actually create our background tile with our background image. I said background a lot, I apologize. So to get started, we're going to comment out our add level real quick and then refresh just so there's nothing on the screen so we can see what this is doing. And now what we need to do is we need to create an actual component that we can use for our background tile. So we can go to components, right click and do new file. We'll call this background underscore tile dot dart, and then we'll actually create a class called background tile, and then this is going to extend a sprite component. A sprite component allows us to pass in an image. It's just a single image. It's not an animation image or anything like that. So that's why we're using sprite component and not sprite animation like we did for the player. But the cool thing is it is a sprite component, so we can give it a sprite. But we also have, it extends a position component, so we can give it a position and all of that stuff. So then we can just make the background tile. We can make the constructor. We're going to pass in a position. And then we don't necessarily need access to this position right now, but we do want to make sure that we pass this into our component, so we can do semicolon super, and then we can just say position is position, because we do want to make sure that we give our sprite component right here our access to our position, which is how we're doing super. Hopefully that makes sense. I explained that a little bit better so in our last video, so you should know what a super does. And then we do also want to get access to our background color that we can pass in. So we'll do final string we'll just call it color for shorter code. And then we just want to make sure that we pass this in as well. And we can do this dot color equals, and then we'll do gray. And we want to do equals because this way we don't necessarily have to pass in a color. But if we don't pass in a color, then we're just going to default to gray. And if we do pass in a color, then we'll use whatever that color is. So very easy to just have that. So we have a default in case we forget to do it or don't want to do it. And then if we do want to do it, we'll just overwrite that. So we can hit save. Perfect. And then what we want to do is we need to actually give this a sprite. So sprite component requires a sprite. So we'll do onload, and we need to give it our actual sprite. So to do this, well, we're going to need to give it a size. So we can do size equals, and then I already know what the size of my images are. So we can do vector2.all. We don't necessarily have to pass in the size. I mean, you could if your tiles were different sizes, but all of our images backgrounds are the same. They're all 64 by 64. So we're just going to write 64. This will also come in handy in a moment because we need to tweak this a little bit. So it's good to just have it dynamically in the code that we are manually setting it rather than it be dynamic. Now that we've given it a size, we also need to give it a sprite. To do that, we can do sprite equals, and then we need to pass in a sprite, and then we just need to give it an image. Well, we already have access to the images from cache from our game itself, so we need to make sure that up on our extend sprite component, we also get a reference to our game. So we can do with has game ref, and then pass in the pixel adventure like we normally do. And now down here in our sprite, we can call game.images.from cache. And I'm going a little fast here, but like I said, this is stuff we've already done. So hopefully it's muscle memory for you at this point. If not, that's fine, but it definitely is for me because I do a lot of these videos beforehand and then change things around, so it's becoming second nature, which is really good about working on the games. When I first started doing this, I didn't know what I was doing. And now I'm like, oh, well, that's simple. I just do this and that. So hopefully that's working the same for you as well. And then we do need to pass in our path to our background. So the path is background. And then we actually can reference our color right here. And then we can do $color. And then that's going to grab our variable for our color. And then all of our colors are PNGs. So we can just do PNG. Perfect. So now that is our background tile that we've created. We can now go back into our level.dart and actually create that background tile. So to do this, we'll do final background tile equals, and then we can reference our background tile that we just made. And then we already know what we need to pass in because we just coded it. So we need to give it a color. Well, the color is going to be our background color. However, our background color could be null, right? Just because we have access to the layer and we've hopefully have access to the property, we might have forgot to add that custom property in our tiled, right? Maybe we didn't add this and we forgot. So it's very important that we check to make sure that this is not null. Otherwise, we're going to pass in an invalid color and it's going to break our game. So to do this, we can do is background color is not equal to null. Then we can do, it's a question. This is called a ternary if statement, ternary function. And essentially we're saying if background is not equal to null, background color is not equal to null, then we're going to use a background color. And since we've already made it a variable, we can actually just call it background, not layer, background color. And then if it is null, then we're going to use a different color, which we'll use gray. And essentially this is saying is we want our color to be, if our background color is not equal to null, we want it to be our background color. If it is null, which means it doesn't exist, then we can just pass in a default color, which in this case is gray. But you see there's a little blue squiggle here. And the reason why is if you're checking to see if something's not null, and then using it if it's not null, you can actually save yourself some code. And if you hit the quick fix, it'll convert to use question mark, which is essentially the same thing. It's questioning, is this null? If it's not null, use it. If it is null, use this. And it makes our code a little cleaner. So definitely cool to use that. And then of course we need to give it a position. And in the position, for right now, we don't actually have a specific position. We'll get to that, but we'll make it a position x0 and y0, which just means the top left. And then don't forget, we also need to hit add and add our background tile to the game. And if we hit save and refresh, we now have our background tile, which is perfect. However, we want this to actually tile because it's just one part of our background. We want this to tile the whole way across to the right, and we want this to tile the whole way across, top and bottom. So how would we do that? Well, the easiest way to do that is a for loop. For loop, we can check to see how many times we need to repeat ourselves and then just repeat ourselves that many times. So to do this, we're going to need to figure out how many times we need to repeat ourselves. And we can actually come outside of our if statement because it's going to stay the same. We can actually do a const, and we need to give us a tile size. Now, again, I know that my tile sizes are going to be 64. So we're just going to hard code that in here. Again, if your images are different, you'd have to get a reference to that. But ours are going to be 64 by 64, no matter what. So we're just going to hard code that number in. But now that we have access to the tile size, what we want to do is some math to figure out how many tiles we need to go on our X so that we can actually loop through it. We're also going to need to know how many we need to do on our Y. So let's go ahead and do our X. Let's go ahead and do our Y first. So we will do final num tiles Y, which is short for number of tiles on our Y, and then we can just pass in a math equation here. So the math equation is going to be, we need to get reference of our game again. So we can do with has game ref, and then we'll pass in pixel adventure just like we did on our background tile, but now we have access to our game, and we can do number of tiles is equal to game.size.x, which is the width of our game, divided by our tile size. So we're saying we need to grab the width of our game, however big this window is, and then we need to divide it, our tile size, which is 64. However, this is going to give us a decimal number, which we don't want. So what we can do is, and the reason why I wrapped it in parentheses, is after that we can actually just floor that, which means get rid of the decimals and round down. So if the number is, I don't know, 9.8, it's just going to round down to 9 because we want whole numbers when we're looping through stuff. We don't want it to be a decimal. That's going to cause some issues. Cool. So now we have access to our number tiles. We can come back inside here. We can actually comment out this stuff for right now. We can come back in here and we can do a for loop. So we can do for, and then we're going to be using our y to do our vector, and our y in a vector needs to be a double. So we'll do for double y is equal to 0, and then we're going to do y is less than. And then what we need to do here is we need to essentially grab the num tiles y. And then we're going to do y++. So hopefully you know what a for loop does, but essentially it's going to start at 0. It's going to check to see if y, which is 0, is less than our number tiles. And then it's going to run all of this code, and then it's going to add 1 and repeat itself until y is no longer less than the number tiles. Hopefully that makes sense. And then if we grab out our code here, we can uncomment it. Don't know why I commented it actually. And then we can go ahead and then for our position, instead of having 0x and 0y, we can pass in our y. However, we want to make sure that we pass in our y times our tile size, because this number is just going to be 0 through 9, right? So we want to make sure that we're passing in our tile size so that we get it correctly. And then we also, if we refresh this, perfect. So now you can see we're looping through and we're repeating ourselves over and over again until we've met the requirements of our game size, which is really awesome. Now I do want to go ahead and this actually helps our code later. We're going to subtract the tile size to begin with because I wanted to start off of the screen. That'll actually come in handy later. Maybe I should have waited to tell you that, but I don't want to have to come back to this later. So we're actually going to subtract our tile size to begin with. So it's going to be y times our tile size. No, that would be right. Yeah, we want a y times our tile size minus our tile size because that's going to help us start with scrolling. That's actually starting up here. You can't really see it because it's off the screen, but it's actually starting up 1 and then coming down. So that'll come in handy later when we do our scrolling pattern. Cool. Now we don't want to just repeat on the y, we also want to repeat on the x horizontally. So to do this, all we have to do is just do another for loop. So we can do inside of our for loop on the y, we can do another for loop for our x. So double x equals 0. And then we just need to get our num tiles, which again, num tiles x. And I actually messed this up. You'll probably, that's probably why it was so many. Let's actually come back to that. But we want to make sure it's num tiles y is equal to game.size.y divided by tile size. And num tiles x is game.size.x divided by tile size. So very important you have those proper. We can actually clean this out real quick and show you now it still looks the same, but it would have actually, if we save and refresh this, you can't really tell, but yeah, it would have looked a little bit different because I repeated them too much because we did it on the y, on the x rather than the y. So a little mistake, but good thing I caught it. So we'll do double x equals 0. X is less than num tiles x, x plus plus, and then we'll do the for loop. And then we can grab out this, and now instead of passing in 0 on our x, we can just do x times tile size. Perfect. And if we refresh, now it's repeating the entire screen, which is great. That's all we have to do to actually create our background tiles. Now, you can probably already see an issue here, though. Our background tiles has these little lines, and it's because this is pixel perfect, but it's just, I don't know how to explain it completely, but it's 64 and 64, and there's just that little bit of a gap. So we are going to fix that, and we can fix that in our background tile. Instead of our size being 64 exactly, we can add a buffer by doing like 64.6, and if we save and reload, it's gonna just push those pixels just a little far, not a whole pixel, but just enough so that they overlap. You can't really tell the difference, but that is the easiest way I found to fix that error. Just because they're butt up right against each other, we can make our size just a little bit bigger than what it's supposed to be, and that's going to stretch those out just a little bit to cover that tiny gap. And then before we get started with our position moving, we do want to make sure that we add a priority here. It'll come in later because right now our background, if we go back to our level and refresh, our background is actually over top of our level. Our level's there, but you can't see it because how we're coding everything. So what we can do here is we can just add in priority and then make it equal to -1. This means it's lower than everything else, and it's going to be behind. We do get this little weird artifacts on the side of our background not butting up against it, but that's fine. If we resize it, we can always get rid of it. It's not something you'll see on the actual game. It's just based on how I have it positioned. And there we go. We were able to get rid of it. But cool. Now we have the background. But what we want to do is we want to actually scroll this background. That was the whole point, is the background needs to scroll. So we can go ahead and do that as well. So first we'll come up to our background tile and we'll do final double. And then we need to pass in a scroll speed, and the scroll speed is going to be very small. It's 0.4. And then we can do our update. We can call our update, and now, well, how do we make something move? Well, it's very simple. All we have to do is grab our position, and in this case, we want it to move on our Y. So we can do position.y plus equal scroll speed. And if we save this, now our background is going to scroll. And I can actually come back to, if we get rid of the minus tile size and refresh, you can see that our background immediately starts scrolling down, right? So that's why I did the minus tile size, because it's going to pull it up 64, and as you can see, it takes a little bit longer to actually do that. That's going to come in handy, so that way when we repeat it, it's still repeating. It's actually repeating above the screen, and you don't really see that happening. That's why I subtracted the tile size. Cool, because we want to work above what you actually see in the game, which is -64 above the screen. Cool. So now we have our position going down, which is great. However, we need it to repeat itself. We need to be able to have this scroll forever. So to do this, well, we're going to need to get reference to our tile size. And we already know what the tile size is, so we're going to just hard code this in, and it's going to be tile size, double tile size is equal to 64. And then what we need to do is we need to figure out how far down we want to scroll, right? We want to know what our scroll height is going to be. Where do we want to scroll at? Well, we can do the same thing that we did with the number of tiles on the Y. We can do int scroll height. Scroll height. And what is that going to be equal to? Well, we already know. We're going to do the parentheses. It's going to be game.size.y, which is the height of our game. And then we're going to divide that by our tile size that we pushed in there. And then we are getting an error because that's a double and we need it as an int, and then we can do floor. There we go. So now we have int scroll height, and then we can do, essentially it's doing the same thing that we did on our level for the number of tiles. We're just doing it that way. And now that we have our tile size and our scroll height, we just need to check to see if our position.y is greater than our scroll height. So we can do if position.y is greater than our scroll height, keep in mind this is just a couple numbers, so we want to make sure that we multiply it by our tile size, then we want to do something. And what do we want to do? Well, it's very simple. We just want to set our position.y to be equal to negative tile size. Now, if this is a little confusing, what we're saying is we want our position.y to be 0, but we don't want it to be 0 like I said earlier, because you'll see it repeating itself at the top. If we didn't have the level covering the borders, you would actually see it, so it's better to just do it off screen, which is negative 64, which in this case is negative tile size. So we're setting our position to start at negative tile size, negative 64, and we're setting our position when it repeats itself. When it gets to the bottom, it goes back to the top. We're going to have it go to the top, but negative 64. So again, everything is happening off screen. Hopefully that makes sense. Please let me know in the comments if it doesn't. But as you can see, it repeated itself. And now if we refresh, it's doing that. It's repeating over and over and over. However, you can see that there's a little issue here. There's always that little gap. Let's see. Yep, there we go. There's always that little gap of that happening. And that took me forever to kind of figure out. And we need to go ahead and tweak that. And to fix this, what we need to do is go into our level.dart file. And right here where we're checking our initial for loop of if y is equal to 0, we need to check to see if y is less than not number tiles y, but what we need to do is we need to get a reference of our game size again. So to fix this, we need to do is y is less than game.size.y divided by our number tiles.y. So essentially what we're doing is we're grabbing our game size height, or game's height, we're dividing it by 64 and getting a number rounded down. We're then grabbing that number, but then we need to grab our height of our game again and divide that by the number of tiles needed to actually calculate that. And it's a weird thing, I know, but if you save it and refresh, it just works. So that's the only downside about coding. Some things it just doesn't make any sense. Why would we have to do that is something we have to do. So for our y, we're checking to see if our height of our game divided by the numbers of tiles, and then we're just essentially doing it again. And for some reason, it just works perfect when we do it that way, rather than just grabbing the number of the tiles. So if anyone can let me know exactly why that works perfect, it might actually be because we're flooring it here and we're not flooring it here. But that I'm not sure. So, but it works, and that's good enough for me. So now we have the scrolling background. We can go ahead and uncomment our level and refresh, and now we have our scrolling backgrounds forever, and we can go ahead and continue on. The best part about this though is our code, our background colors are now dynamic. So if we go back to tiled and say this is blue, we can then go ahead and refresh our game, and now our background is blue. And then if we have a different level, let's say that level is purple, we can save, and then we can go ahead and make that background purple. So definitely awesome. That's why we want to do it this way. That way we can give specific backgrounds for specific levels. I forgot to save, and then we'll just go back to gray. There we go. So now that we have our scrolling background, what we want to be able to do is we want to add in fruit. So to do this, we're going to go back to our tiled, and we hopefully already know how to add in stuff. We're going to go to our background layer, and we're going to just tweak our design a little bit, so that way we can add in this fruit that I want to add, just so it looks a little bit nicer. We will and you can make the map look however you want. That is completely fine, but we're going to make these blocks 4 wide instead of 3 wide, and then we want to switch up the collisions real quick and just drag them over, and then drag these over as well. Perfect. And then we can hit save. So now what we want to do is we want to go to our spawn points and we want to just put in where we want to add fruit. So we can do that by coming up to the insert rectangle, and then we can just drag out. Now our fruit is going to take up 64, it's going to take up 32, just like our player, 32 by 32. So make sure that when you do drag that out, you do drag out a square of 2 blocks, 32 by 32. And then you probably know what we're going to want to do. We're going to want to pass in a class called fruit. But not only can we add a class called fruit, which we'll search for, we can also call a name. We can add a name, and then we can give it a name. So in this case, we have a bunch of different fruits. We'll do bananas here. We can go back to the select tool at the top. Control C and Control V. Let's say we want this to be cherries. Again, bananas and cherries. We can copy that, paste it. Let's say we want this to be apple. Let's say we want 2 more here of cherries. We'll actually do 3 because that's kind of what they do in the design. And we'll do 3 here. There we go. And then over here we can do in the middle, we can do kiwi. I like kiwi. I think the kiwi sprites is very cute. Okay, cool. So we've added in some kiwi. We've added in 3 cherries and 3 cherries. We've added in apples, bananas. I believe, what is our other items? Items, fruits. We have orange. Let's go ahead and add in an orange here. So what we're doing is we're making sure that all of our fruit have a class of fruit, but then depending on what fruit we want to spawn, we're going to give it a name of whatever that fruit is to match our sprites. So we can hit save. We got some kiwi, cherries, banana, orange, and apple. And then we can go back to our code. First, we of course want to bring in that folder so we don't forget. We can go to our pubspec YAML, and then right under our HUD, we can do, where's the path? The path is items, capital I, and then fruits with an S, and don't forget the slash at the end. So that's going to save all of those. Perfect. We can get rid of our background tile. We're still going to use our level.dart file, so we can do that now. So, well, we already know how to spawn in objects, so we can minimize our scrolling background since we're done. We want to be able to spawn in our fruit. Well, how do we do that? Well, it's very simple. We already have a switch case for the class, so we just need to add another class here. So we'll do case. This time it's fruit, so this is our class that we're looking for. And then what we need to do is create and just add our fruit. So we need to make a class for that. So we can go to components, new file, and we'll call it fruit.dart. And then we can do a class for the fruit. So class fruit. And it's going to extend, a sprite animation component because we're going to be able to give our fruit some animations. We want to make sure that we do, and therefore that we need to pass that in. And then just like before, we need to create a constructor for our fruit, and our fruit is going to take in a position and a size, and then we can pass that to our super. So we'll do super and then position and then size. Perfect. And then we need to pass in a name, right? We gave our fruit a name, so we need to pass that in as well. So we'll do final string fruit, which is the name of our fruit, and then we'll just give it this dot fruit equals, and then by default we'll make it apple if we didn't pass in anything. Again, I like to add the defaults in case we don't pass it in, just so it doesn't, break everything. Cool. So now with it having a sprite animation component, we need to set up the actual animation kind of like we did for our player. So we can go ahead, and if you remember how we did it for our player, if not, that's fine. But we'll do final double, and then we need to give it a step time, and then this was 0.05. That's equals 0.05. This is our animation time, how long it's going to be displaying. And then what we need to do is we need to go into our onload event. And then we need to give it an animation. So to do this, we can do animation equals sprite animation dot from frame data, right? Remember, we're using frame data, which means it's a horizontal. All of our frames are on one line. If you go into our apples, all of our images are on one line. And that's what from frame data means. And then we can go ahead and, well, actually, that means we're grabbing an image, but it is a horizontal image. And we do need access to our image. So we're going to have to do with has game ref pixel adventure. Perfect. Just like before. And then we just need to pass in our game, or our images is going to be game.images dot from cache. And then what is the path to our image? Well, the path is items / fruits. And then we can pass in the fruit that we're passing in right here, fruit passing in, and then .png, just kind of like how we did the other thing, the background tile, right? So items, fruits, and then fruit as the actual fruit itself, and then .png. Cool, which in this case is apple. Always make sure it's capital, by the way. And then what we need to do is we need to tell this what kind of frame data is this. And this is what I was talking about, it being one whole line of images. That means it's sequenced. So we're going to pass in sprite animation data dot sequence, which means it's in a straight line. And then we just need to give it this information. The amount for all of our fruit is 17, so we can just hard code that in. Our step time is step time because that is our animation time, like frames per second essentially. And then for the texture size, we already know what this is. I mentioned it earlier. It's vector2.all 32. And then we can save this. Perfect. And then if we hit save and reload, nothing's going to happen because we're not bringing in that fruit. But now we can. So we can go back to our level.dart and we just need to create a fruit. So we'll do final fruits equals, and then it's going to be a fruit. And then we need to pass in a few things. First, we're going to pass in our fruit. Well, what is our fruit? Well, our fruit is the name in tiled that we gave it. So we need to get access to this name. And that's very easy. We just need to do spawn point dot name. That simple, right? And that's one thing I love about using tiled and with Flame is that stuff that we need is built right in and we have access to all of it very easily. And then we also need to give it a position, and the position is going to be vector2, and then we just need spawn point.x, which is the x of where it is, and then spawn point.y, which is the y of where it is. And then for the size, we just need to do vector2, and you probably know what this is, spawn point.width and spawn point.height. Perfect. And then if we save, we want to make sure that we add our fruit. Don't forget to add the fruit or you won't see it. Perfect. And then we can refresh, and nothing happened. Well, actually it did. Look, all of our fruit is right here. That's awesome. But why? Well, we messed up in our code. That's why. So for position, we actually need position. And for our size, we need size. Sorry about that. Hopefully you caught that before I did. Now we can save and refresh. And our fruit is where it is. And the best part is it's animating. And we can go over and, well, we can't collect it yet, but we can actually see our fruit. Now we have an option here because as you can see, the fruit is in front of the player. And that's up to you if you want it to be in front of the player or behind the player. If you want it to be behind the player, we can do priority equals -1. And then this will kind of actually put the fruit behind the player. I think in the images of the game, it was behind the player, so we'll do it this way. But your preference, however you want, but that's how you put it behind the player or not behind the player. So we'll keep it behind the player. Now, what we need to do though is we need to actually add in some collision. So that way, when our player does go over the fruit, it actually collects the fruit. So to do this, first what we want to do is on our onload, we need to do a debug mode is equal to true. This way we can actually see the rectangles of our fruit. And as you can see, it's much bigger than our fruit. So what we're going to have to do is we're going to have to add an actual hitbox that we can use. And we can do this kind of like how we did for our player. We can do... We'll do it under the step time. We'll do final hitbox equals. Now we do have our hitbox right here, player underscore hitbox, but I don't want to use a player hitbox for my fruit because that's unrelated, but I do want to reuse this code. So instead of calling it player hitbox, we can hit Control D and then call this custom hitbox. Now we can rename this to custom hitbox as well. Rename custom hitbox. And then this is going to pop this up. Yes, hit OK. And then this is going to break our player because we're now passing in a player hitbox that doesn't exist. So we can hit Control D and then call it custom hitbox. I do want to use this so I can use it on a lot of different things. And then we just make sure you hit refresh. And then that's going to fix that. So instead of using our player hitbox for our player, we're going to use the custom hitbox because it's the same type of hitbox. And then for our fruit, now we can use a custom hitbox as well and pass in the same information. This saves us a step of having different hitboxes because they're going to do the exact same thing. We don't need them to be different, but that is something where you could have made a whole custom one if you wanted to. Now with the custom hitbox, we just need to kind of position our hitbox around here. I already know what codes I like, so we'll do 10, 10, 12, and 12, but essentially you would just give it a number that is very close to the fruit. Now we're not using the hitbox yet, so we can do so by right under our priority. We can do add, and then we'll add a rectangle hitbox. And then the rectangle hitbox, we just kind of need to grab our hitbox information and use that. So we're going to pass in a position, and the position is going to be a vector2. And then it is going to be hitbox.offset x and hitbox.offset y. So this is where our stuff is going to start. And then the size is also going to be a vector2. And this is going to be the hitbox.width and the hitbox.height. So essentially we're going to add a rectangle hitbox. And this rectangle hitbox is going to have a position that's going to start with our offset x and our offset y, and then it's going to be the size of our hitbox width and our hitbox height. And we save and refresh that. Perfect. And if you can see this, I'll zoom in a little bit, you can see that our squares are just right near the fruit rather than this big section. It's going to be right here. So only when our player is right here will actually trigger. And yes, our background repeating does break if you resize the screen. That's something that we necessarily don't have to fix right now, but that's why it does that. So just keep that in mind. You just have to refresh if you resize it because it is going to break at the moment. Maybe we'll fix that in the future. And then we do want to give this a rectangle hitbox a collision type, and then the collision type is just going to be passive. This just kind of saves some resources because it's only going to check collision with our against our player rather than against each other. I don't care if they collide each other. They don't need to track that. So it just kind of saves us a step by not checking that. So that's good there then. And then since we've added in our hitbox and we actually want our player to be able to collide with these, we need to actually pass in collision detection. So after the with has game ref, we can do collision callbacks. And because we're using collision callbacks, we also need to do that with our player. Our player is also going to have collision callbacks, but also our pixel adventure file, we're going to have to add collision detection. So not collision callbacks here. This one is called has collision detection. Collision. All right. So our game file needs to has collision detection, and then our stuff that we need to collide are going to have collision callbacks. Now our player's already set up perfectly to work with this because we did add a rectangle hitbox before for our player. So that works perfect. And now we have a hitbox for our fruit. So that works perfect as well. What we want to be able to do now is we want to actually get rid of our fruit when our player collides with it. So now that we have collision detection, under our onload event, we can actually call our collision detection. And we don't necessarily want to call it on our fruit. I mean, we could call it on our fruit if our fruit collides with a player, but our player is the one moving, so it's going to be better to call it on our player. If our player collides with something else, especially because we're going to add this in later when we add installs, which will hopefully be our next video, we want to just add all of the collision detection to our player rather than to the fruit. So what we can do here is we can come into our code, find a nice spot to put this stuff. We can do it right below our on key event, and we'll do on collision. And the on collision allows us to check an other, and we can actually just do if other is, and then we can pass in a class. So this is saying if we collide with something and it is a fruit, then we can run some code. So the first code we're going to want to run is we can just print colliding, make sure everything that works, and then we can hit Control tab and then go to debug console and refresh, and then we can actually run over there and see, and we should see as soon as we're colliding with it, we are colliding. Now we could turn on the debug for our player if you want to make sure that it's colliding properly. Now we can see that our hitbox is in fact colliding with its hitbox. Again, you have to make sure that the hitboxes are colliding, but we don't really need to see ours because it's the size of our player. Cool. So now that we're colliding, what do we want to do? Well, what we want to do is we want to do whatever fruit says to do, and we can do this by actually creating a method in our fruit and then calling that method when we collide with something. This is the best approach. If our player collides with something, well, we're going to check to see if it is. Great. And if it is, then we're going to call whatever that thing's is method and how to handle its collision. So we can do this by coming down here, and we'll actually, just to save ourselves a step, we'll do, we don't want it private because it's going to be called from something else. So we'll do colliding, I spelled that wrong, colliding with player. So when we collide with player, we want to hit create a method, and we actually don't need to call the method, so we can get rid of it, but I use that to create it, void colliding with player. And then what we can do is we just need to call this. So we can actually just print colliding with player. Spelled colliding wrong, but that's fine. But now we can go back into our player, and then when we collide, instead of printing colliding, we can actually just do, and to make it cleaner code, we'll do other dot, other being whatever we're colliding with, other is our fruit in this case, other dot colliding with player. And I guess we should call it colliding, collided rather than colliding, just because we're only going to check it once and then do something. So we'll do collided with player. So I know I went kind of fast, but what we're doing here is we're checking to see if whatever we're colliding with, we're going to check to see if other is fruit. If it is fruit, then we're going to run this code right here. And what is that code? Well, we're just going to say call others, which in this case fruit, method collided with player. And if we refresh and go and collide with the player, with the fruit, it's now saying colliding with player. and then it stops. So it works the same way as before, but now we don't have to have that logic inside of our player. We're just checking to see if our player collides with it. And if our player does collide with it, we're going to tell the object that we're colliding with, it's going to call a method that we want to handle collision, and then handle all of that collision logic inside of the object that we're colliding with. Hopefully that makes sense. I think it does, but if it doesn't, let me know. But instead of printing colliding, what we want to do is we want to handle colliding. Well, how can we do this? Well, let's just say we want to remove it. So we want to do remove from parent, and then this will allow it so that way when our player, let me move my player over a little bit. When our player collides with an object, it just removes it. Perfect. There we go. We've now killed the fruit. Collected the fruit. Not killed it, but we've collected the fruit. Well, that's not exactly what we want. We do want to remove it, which is remove parent. So we definitely do want to use this. However, we want to play an animation when we collect it, right? We want to actually show some feedback, not just make it disappear. So first we can actually comment out our debug mode is true because I don't like all the purple stuff. There we go. Still works the same. But now what we can do is we can add in if we've collected it. And we only want this to run once, right? We only want to collect it once and then we want it to stop. So to do this, we can come into our fruit and we can create a variable. We'll do it at the top, and we're going to create a variable called bool underscore collected, and by default it equals false. We only want this to run once, so if we don't have something that we can check if it's false and then run it and then trigger it to be true, it's going to keep running, and that's going to make our animation look really weird. It's just going to keep repeating itself, so we don't want that. So what we can do is we can come down here. First we're going to check if it's not collected, underscore collected, right? So we only want to run this if collected is equal to false, which means we haven't collected it yet. So if we collide with our player, we're going to check to see if we collected this yet. We haven't, because it's the first time we've collided with our player. Then we can actually run this code. Cool. Well, what code do we want to do? Well, we want to switch out our animation from our fruit to our collected animation. If you go inside of our fruits, there's actually one called collected, and this is a frame animation as well of 6 frames, and it shows us collecting our fruit. So just like what we did before with our animation up here, we can actually just copy this, save ourselves some time. We're going to set our animation to, instead of fruit, it's just collected. Capital C, collected. And then instead of being 17, it was only 6. And the size is the same and all of that. Perfect. And then if we go over here and click it, and of course we want to make sure that we comment out removed from parent. Otherwise, we're not going to see the animation because we're going to remove from parent. So now one issue that we have here is once we collect it, well, it's stopping on our animation, right? And this is why I said earlier, it's just going to keep repeating our animation to the first frame if we don't actually set our collected. So we want to first go ahead and check if underscore collected. Then if it is, which means it's not collected yet, then we want to run the animation, but we also want to set collected is equal to true because we only want this to run once. So if we refresh this, there we go. Now we can click it, and even if we stand on it, it still runs the animation. Now we are running into another issue here, and this issue is it's looping. We don't want it to loop. We only want this animation to play once. So we can come over here in sequence and write loop equals false. Perfect. And if we refresh, then it'll only play once. But then I don't know if you can see it, but the last animation is still there. Yeah, I'm glad that our background breaks. So you can see it now. So the last animation is still there. And the reason why it's still there is because it's only running once and the last animation isn't blank and our object is still there. So at that point, once everything runs, then we want to remove it from parent. And the easiest way to do this is we can just add in a delay after the animation. So we can do, we can comment that out. Cut that out. We can do future dot delayed, And then we need to give it a duration. Now, really, the duration you can just kind of mess with. We can do const duration. And then we're going to pass in milliseconds. And then I was just messing with the code. I think 400 feels good, but you can do it however you want. Also, let me know if there's a better way to do this. I was wishing we could just do it after like it's completed, but I wasn't able to find like on complete of the animation. So I'm just going to use it as a delay. But please let me know if there's a way to just make it where after the animation goes, then we run something else. Maybe a dot then might work. I'm not sure. So we'll do that then. And then we can do, we need to pass in a function. And then the function we're going to pass in is just going to be removed from parent. And then we can get rid of this. So essentially what this is doing is we're calling it delayed, which just means that we're going to delay something. We're going to delay it a certain amount of time. In this case, the milliseconds, in milliseconds of 400. And then once we do that, it's going to remove from parent. So we're going to essentially collect it, play the animation, and then remove it from parent at the very last second so that the animation disappears. And if we make this big, again, it's going to break our code here. If we, if I can open that up again, if we make this big and refresh it, here we go. So now when we go over our object, it plays the animation. Poof, poof. It plays the animation and then it goes away. So plays the animation and goes away. Plays the animation and then goes away. And there we go. We can now collect fruit. And this is kind of how we would handle collision detection in our game. And we'll be using the same thing with our saws and stuff like that. But yeah, we're pretty much good to go. We have our scrolling background. We now have the ability to collect fruit. Again, it is behind our player. If you want, you can put it in front of your player, but behind is how they had it. And yeah, we are able to collect the fruits and spawn it in. And yeah, I was really excited when we got to this point. This wasn't that complicated, I hope. And yeah, I hope you guys enjoyed this video. Definitely subscribe if you haven't already. In our next video, we're going to be working on adding the saws into our game and actually, you know, getting hurt and respawning. So that should be interesting. And yeah, I'll see you in that video.